Going on guys, let's do this problem right here. The question is asking whether this function converges or diverges, right? That's the question. So let's see how we can figure it out. So whenever we have series and if the limit n approaches infinity, and if we have an that is not equal to 0, we can say this is sigma an is it diverges. So it's always true in a series. And if it's equal to 0, let's say if limit n approaches infinity and an is equal to 0, this is a complicated situation. We can't determine, like we can say it may diverge or it may converge, right? It may converge. So from this one, we know that if we get an answer that is not equal to 0, that's very easy because we can directly conclude this one diverges. So let's see whether we get 0 or not. If we don't get 0, that automatically diverges. So let's see how we can find this out. So first what I'm going to do, I'm going to take this function right here. Sigma n is equal to 1, infinity, ln, and let's take the common denominator. So here if I take the common denominator, this is going to be n over n, like this can be written as n over n, right? 1, same thing, 1 and n over n, if you divide you will get the 1. So it's going to be same thing, 1 over n, and let's write this one together and see what we get. N is equal to 1, infinity, ln n plus 1 over n, right? So whenever we have natural logarithm, if it's multiply, we add them. If it's divide, we subtract them, right? So we can write this expression in a different way. Like sigma n is equal to 1, infinity, ln n plus 1 minus ln n, right? So we can write this one in this expression. And let's apply some value and see what we get. So for example, if we apply 1 for this n value, we will get ln, so it's going from 1 to infinity. So we can go ahead and write all the terms. But let's write some terms and see what happens. So here we are going to get ln 2 minus ln 1, right? So it's going to go like this, ln 2 minus ln 1. The next one is going to be, if it's 2, if the n is equal to 2, this is going to be ln 3 minus ln 2, right? So it's going to go like this. The next one, if you apply 3, this is going to be ln 4 minus ln 3. And if you apply 4 for this n value, that's going to be ln 4, actually it's ln 5. We finished at 3, then 4, yeah. So this is going to be ln 5 minus ln, so we add them together, right? This is going to be addition. All of them are going to be addition, and ln 4, and it goes like this. It goes so until infinity. So it's going to go until infinity. So let's look at some values. For example, if I take until S4, like 4 terms, and 4 terms mean it's going to end at this point. N is equal to 4, so it's going to be 4 plus 1, that's going to be 5. So it's going to end at this point. So exactly right here. So S4, let's do the summation and see what we get. So we know that ln 1 is equal to 0, so we can cancel this one. And if you look at this one, ln 2, here we have positive ln 2, and here we have negative ln 2. So this one will cancel with this one. So, and this one will cancel with this one, and this one will cancel with this one, and only we will get ln 5. So ln 5 is going to be answer. And if you take S5, we are going to have one more term, that's going to be ln 6 minus ln 5, and all the other terms will cancel and you will end up with ln 6. So it seems like if it's Sn, we will get ln n plus 1. So that's going to be the final answer, right? So that's going to be the value, that's going to be the end point of this one. So whatever the value you pick, you will get one more right here. So that's the pattern is going on right here. So here what we can do, we can take this one into limit n approaches 0 ln n plus 1, and if you apply n infinity for n, this is gonna be ln infinity, right? Infinity plus 1, that's gonna be ln infinity. So if it's, let's draw the ln graph and see what happens. So here we have the ln graph. So as x approaches infinity, y goes to infinity, right? So the answer is going to be infinity. So we know that if it's infinity, it's not equal to 0. So it satisfies the first condition right here. Ln n approaches infinity, not equal to 0. So that means it automatically diverges. So the answer for this one is going to be diverges. And that's how we do these kind of problems. I hope you guys find this video helpful. See you next time.